Today we shall be discussing nodal and mesh analysis. Okay. Let's have some talks about basic nodal and mesh analysis. These topics are easy, but you need to have a lot of practice for questions. Okay, these are the topics from which questions are asked not only in ESC prelims, but are also asked in ESC mains, IAS mains, and gate exam as well. So I'll be taking into consideration all these four exams regarding these topics, and we will get a clear view regarding these topics in the videos I will be posting regarding numericals. Okay, I will be solving previous year's papers regarding not only ESC prelims but also ESC mains, IAS mains, and gate. Okay, I will try my level best, and these concepts now are just plain words to you, but while solving questions we will have a better understanding of this topic. So let's get started. We have nodal, and we use node voltages here, and we count the total number of nodes, assign the reference node, apply KCL at the node. Okay, and this is the format: high voltage minus low voltage upon resistance. This is the particular thing we are using to form an equation. Okay, and suppose this is a circuit and these are the nodes, these points are the nodes. So we are taking any node of our choice into reference depending upon on which segment a node voltage is being asked. A voltage regarding any element is being asked. Okay, so we take node accordingly. Now let's talk about cases. If voltage source is connected between the reference node and a non-reference node, we simply set the voltage at the non-reference node equal to the voltage of the voltage source. Here let's see, if this is suppose a reference node and this is a non-reference node, and if we are having a voltage source across it, then what do? We consider the non-reference voltage equals to the reference voltage. Okay, in case 2, if the voltage source, now here it gets a bit complicated, it is if the voltage source dependent or independent is connected between two non-reference nodes, and the two non-reference nodes from a generalized node or super node, and we apply both KVL and KCL to determine node voltages. Okay, now suppose this is your reference node, and here it is a voltage source between two nodes which are non-reference. Okay, this is our reference node and these are non-reference nodes, and we are having a voltage source between two non-reference nodes. So what we are doing, we are combining these two nodes to form a single node, and this single node is called a super node, and on this node we are applying both KVL and KCL to find out the node voltages. Okay, according to this question, this could be the solution. Okay, here we have, because this is the reference node over here, we have these sets of equation, and we are solving. Okay, this may be, I will be explaining this particular stuff while solving question. Okay, now always pay close attention to plus and minus signs, because this is where you get the right or wrong answer. Even though you are performing all the processes right and you are doing everything is correct, but a negative positive sign makes a lot of difference to your answer. Now super node has no voltage on its own. Okay, these are certain points to remember because these things come in your ESC prelims exam. And super node applies both KVL and KCL. Voltage source inside the super node provides a constraint equation needed to solve for the node voltages. Now let's talk about mesh analysis. Here we are using mesh currents. In nodal analysis we use node voltages. In mesh analysis we use mesh currents. Let's talk about what a mesh is. A mesh is a loop which doesn't have any other loop inside it. Okay, this single thing could be a mesh and this single thing could be a mesh. Okay, this particular loop and this particular loop could be a mesh, but this particular loop is not a mesh. Okay, a loop within a loop is not a mesh. Now let's talk about the equations we are going to form. We are performing basic KVL over here. Okay, and the direction of current is arbitrary, means we are taking direction of currents as per our own convenience. Okay, we will take any direction we want, and according to the direction of current we will put positive and negative, and when we will get the answer, If the answer is coming positive in nature, then the convention you are taking current is correct. But if the answer is coming negative, you need to reverse your current. If you are writing that the current flows in this direction and the answer is coming negative, so in answer you have to write the current is flowing from this to this path. Okay, and this is what the negative sign creates a difference. Okay, now let's talk about, if n is the number of nodes and b is the number of branches and l is the number of independent loops or meshes, then l equals to b minus n plus 1. This is a question that has been asked in the previous year's questions of ESC prelims. Okay, these are the small things you need to remember. Now let's talk about, if l equals to number of equations required to solve circuit using mesh analysis. So this is the number of equations to solve. L is the number of equation. L is also the number of independent loops, plus it is also the number of equations required to solve a circuit using mesh analysis. Now we have equation reduced. Okay, number of equations we can be reduced because